Hi everyone, this is the last part of this tutorial series. In this part we are going to do two things. We are going to implement panning the camera using the right mouse button, and we are going to implement jumping to specific locations using signals. In our project, we are first going to add another input action key. Go to our project setting, input map, and add the command camera pan. We're going to set it to be activated by the right mouse button. And now we're going to go back to our RTS camera controller script and add some new parameters. So the parameters we are going to need are the pan speed. You see it defaulted to a very low number and a very low range, and we only need very small numbers to get a very large movement of the camera. We are going to add the flag allow pan so that we can deactivate this property from the editor. And we are adding another parameter called isPanning, and we are going to use it in a very similar way to how we used rotating. So very similar, we can really just copy and paste the if statement of camera rotate and just replace it with camera pan and camera pan. And instead of setting is rotating to be true, we are setting is panning in both of these code snippets. And again, we need to update the last mouse position so that we can drag according to the last movement we made. Next, in our process function, we're going to call the function pan, and again we're going to send delta to this function as a parameter. We now go to our movement function and add this function here. It is again going to be a private function, getting on float and returning nothing. The function is going to work like this. We first will get the mouse displacement. We transform the displacement into velocity, and we apply this velocity to the camera object. Okay, let's start and do it. So we already made a lot of the hard work before, so variable displacement is just going to be get mouse displacement. The velocity is going to be the displacement, and we are going to multiply by delta and by pan speed, and then all we need to do is translation minus gets, because we want to get the feeling of dragging, so we want to move in the opposite direction of where the mouse is moving. So we're going to remove or subtract velocity from our vector, and here I finally was able to spell velocity, and this should already work. Let's press F5. So just before we can really run it, the displacement is a vector 2 and the translation is a vector 3. So instead of simply doing what I just did here, we need to transform the displacement from vector 2 to vector 3. So we can do it by defining a new vector 3, giving it the same x value as displacement. Y is an axis that we are not moving our camera in, and instead of the z value, we're going to give it the y value of displacement. And now velocity is a vector 3, and if we run it now, we we're seeing that we are always dragging the camera to where our mouse is moving. So we'll add here the if statement. If not is panning, or not allow pan, simply return and do nothing. And now you see we are stationary, and when I press the right mouse button I can drag the camera around. And if we go to our editor and we want to increase the speed that we are panning, we can give it some very high value. You see that 5 is already going to be way too much. So you see every small movement of the mouse just shoots the camera around, which is not very nice and intuitive. But you can see that if I give it some low value, it's also very annoying because I have to scroll a lot to get anywhere. So I think 2 was a good value, and I think we're officially finished with all the functionality that we want. We have panning, rotating, changing the elevation, zooming in and out towards the mouse, and moving with the keyboard. So this is, I think, a very good start, at least for a commercial RTS camera controller. And you can use the link in the description to get the final code and final version and use it yourself. One last thing we wanted to do is allow the camera to jump to specific locations and also lock its movement. These two behaviors are very useful if you are planning on making any game with this camera. For example, in games like Civilization 6, at the beginning of your turn, the camera is going to jump to the first unit you have that have actions. So we need a way to let the camera know to jump to a specific location. This behavior also happens in any RTS game with a minimap. We can click the minimap and immediately the camera moves to where we clicked. So this is the functionality we want to implement now. And another one is stopping the camera from moving using the code. And this behavior might be desired if you open up a menu and you don't want the camera to keep moving and everything to keep responding to user input when a menu is open. So let's begin by making these two behaviors. The way I'm going to set up the events here is slightly different from the one in the GitHub, because here I have full control on the project, and personally I think that event buses are the way to go in Godot. So I implemented this script. It is a script that inherits from a node. We have 3 signals. Camera moved, that is going to let any object that catches this signal the new location of the camera. Camera jump requested. This is a signal that any object can emit, and if he emits this signal, the camera is going to catch this signal with the location and duration and jump to the location specified in the duration amount of seconds. Another signal we are going to use is camera freeze requested. Every object that emits this signal is going to cause the camera to freeze, and I will add here signal camera defreeze requested. And of course, any object that emits this signal is going to make the camera work again. So the first 3 signals that we are going to handle are the camera moved and the camera freeze and unfreeze. Maybe unfreeze is better. Yeah. So the camera freeze and unfreeze. We're going to go to our RTS camera controller, and we want a simple way to emit this signal, the signal camera moved, every time the translation of our RTS camera controller changes. So I can go ahead and every time I change the translation, add this the emission of this signal, but a better way to do it would be to add a function, and we're going to call it translate location, and we're going to send it a vector 3, and we're going to return nothing from this function. And translate location is simply going to do the following. It's going to take the translation of our object and add the vector we received, and also get events and emit the signal camera moved with our new translation. And in order to get this events to show up, we auto-loaded this script that I just showed you using project setting. We're going to auto-load, and here we can use this button to go over all our scripts, and every script that inherits from a node can be auto-loaded. So for example, if I click events again, I can edit with this button here, and I can change the name here, but I already loaded it, so now we have this events parameter that we can use from everywhere in our project. So whenever we translate the location, we move and then emit the signal, and now everywhere we move the camera, for example here, we can simply change to translate location, and the amount we are translating is displacement, and we are just going to go over our entire code and do the same thing. And that's it for the camera moved signal. We are now going to handle the camera freeze and unfreeze. So we are going to add a new parameter. It's going to be a bool, and it's going to have it's going to be called is frozen, and it's going to be initialized to be false. And in our process function, before we do anything, we're going to test if frozen is frozen. Just return, do nothing. If we are frozen, don't move, don't rotate, don't zoom, and don't pan. So now we need two functions that the signals will use. So we're going to implement the function freeze. It's going to return nothing, and it's going to simply set is frozen to be true. And we have another function called unfreeze, and again it's going to return nothing, and it's going to set is frozen to be false. Now we are going to override another function, the ready function. In this function we are going to connect the signals from events. So events connect camera freeze requested. We're going to connect it to a function in this object called freeze. We're going to do the same with the unfreeze. And that is it. We now want to test if this is working, so we are going to create under our main a new control node. We're going to call it UI. We are going to scale it to fit the entire screen, and we are using the unhandled input, so we need to prevent this UI from handling all the inputs, so we set the mouse filter to be ignore. We will then add a button. We are going to add the title toggle freeze. We are going to make it a little bit slightly bigger, and we are going to attach a script to this button, and we are going to call it freeze button. Freeze button is going to have a parameter called is frozen, and it's going to be initialized to be false. Now we go to our button, under the node tab, we're going to connect the pressed signal of our button to the button itself, and we're going to toggle the is frozen. So we set is frozen is not is going to be equal not the value it is currently, and now we're going to add an if else statement. We're going to say if is frozen, we want events to emit the signal. We are currently frozen, so we need to unfreeze. Otherwise, we want events to emit the signal freeze. So now when we press the button, we're going to toggle the is frozen of the camera itself. So now if I press play, you see that I'm able to move around, rotate, move up and down, and if I toggle the freeze button, I can't do anything. I'm pressing the buttons and the mouse, nothing happens. And if I press it again, we can again pan, rotate, and move around, and of course zoom. So we handled the freezing and unfreezing of the camera. The last thing I want to implement is the jumping. So for that I did some of the hard work already. So I went into project and I added a request to jump action under the J button. I added a script to our main node, and the script is going to work like this. If we request a jump, we get a random jump requester, and we are calling the request jump button. And what is a jump requester? So we're going to go to another script. It is a spatial node called jump requester. It is going to have a duration variable, which is the length of the time that we want the jump to take. We are going to first add it to a group called jump requesters, and it has a single function called request jump, and it's simply asking events to emit the signal camera jump request, and it's going to send the translation of this object and the duration that we set with this export parameter. So and again back to main. So this function, you can look at it, we simply get all the node that are in a group jump requesters. We're going to pick at random one of them. We're going to make sure it is not the last one that we picked, because we don't want to repeatedly jump to the same position. It's going to be very boring. And then we return this random requester, and after the input function get this requester, it is using the request jump, and using signals we're going to call the camera to jump to our current location. So all we need to do now is implement this functionality in the RTS camera controller. So we're going to go to our movement functions. We're going to add one function. It's going to be called jump to location. It is going to get two parameters, location, which is a vector 3, and duration, which is going to be a float. It is going to return nothing, and we're going to add another function, and we're going to implement both of them very shortly. So the last function is going to be called end jump, and end jump is again going to return nothing, and for now it is going to just call the unfreeze function. But in the future, maybe you want to also change the zoom, maybe you also want to do some other movements when you finish this jump. So I'm leaving this function here, so it would be very easy to change the behavior at the end of the jump. So our RTS camera controller is going to get another child node, and this child node is going to be of type tween. We're going to cache this node again, because we don't want every time a jump is called to search for this node again. So we are going to add another title for jump. We are going to add another onReady var called tween. It is going to be our tween child node. We're going to go to the jump location, and we are going to ask our tween to first of all stop all the tweens that he is currently working on, because let's say we repeatedly press the request jump button, the tween is going to act very oddly, and it's going to look very weird. So we first of all stop all the tweens. We freeze the camera, because we don't want during the jump for our player to press any key and change the trajectory that we are going on. So this is the prerequisite for the jump. We are then going to call tween, interpolate property. We're going to interpolate our own property, and we are going to interpolate our translation, and we need to send it as a string. I'm going to slightly clean this up because it's going to be a very long line. So the initial value is going to be translation, our current translation. The final location, the final place we want to be is the location we get here with the camera. The time is going to be duration, again the value we get for this function. We are going to use tween. I'll just try and find it. I want the sign, yeah, transition sign, and I want the tween simply is out, and then we need to ask our tween to start, and we want, when this tween finishes, to call the end jump function. So we're going to go again to our ready function. We're going to take the tween and connect the tween all completed signal to our end jump function. And lastly, we're going to take events and going to connect the camera jump requested to our jump to location function. And now you can see that I went ahead and in my scene attached to all of my boxes the jump requester script, and if I press run, you can see that, let me just set this camera to so it will be able to look at it better, and if I press the jump button, I jump to a random box. This concludes our tutorial series. If you have any questions, ask them in the comments and I will answer. I am planning on making more tutorials on Godot. If you have requests for specific topics, I would love to hear them. Thank you for your time and see you next time. Goodbye.